see how the enolate chemistry is used to prepare or synthesize various kinds of organic compounds. So this is the first example of the enolate ion, and we can see that the enolate has a alpha carbon. What do you mean by an alpha carbon? Alpha carbon is a carbon which is attached to the carbonyl. So there's an alpha carbon and the hydrogen is called as the alpha hydrogen. So you can see when I will abstract the proton from the alpha hydrogen, the resulting negative charge is stabilized. How this resulting negative charge is stabilized? You can see the resulting negative charge is stabilized because of the structures, because of the resonance stability. Now, there are two examples where it contains two alpha carbon. The first example contained only one alpha hydrogen, but this is an example which contains two alpha hydrogens, and you can easily see that the resulting negative charge is stabilized. Now, if I draw the other resonating structure, this is not called as the enolate ion, this is called as the carba anion. A carbon bearing a negative charge is called as the carba anion. So once I draw the carbon ion by removing the proton from the alpha carbon, this is a resonant stabilized structure. Why? Because the negative charge can go like this and oxygen will acquire a negative charge. और वो जो structure बनेगा, that will be called as the enolate. That would be called as the enolate. The first example of such structures which we have discussed yesterday are Malonic Ester. Now, what is Malonic Ester and what is the significance? You can go through my previous lecture and see the importance. Why Malonic Ester is the first kind of such compounds? Because they contain a CH2 group. ये बीच में दिख रहा है CH2 group, not these carbons, but this CH2 group is sandwiched between these two carbonyls, making this CH2 highly acidic in nature. It is also called as the active methylene group. I repeat, it is also called as the active methylene group. Methylene का मतलब होता है CH2. So I repeat, so this is malonic ester. This is malonic ester, and this is used to prepare various kinds of organic compounds. We'll see it gradually, but let me first signify the importance of this malonic ester. It contains an active CH2 group, which means that the methylene group is highly acidic in nature, which can be abstracted with a base. I'm using a base, sodium ethoxide. So when I'm going to use the base, I will develop a negative charge here, CH negative. This CH negative, which means carbon bearing a negative charge, is called as a carbon ion, which can undergo a nucleophilic substitution SN2 kind of a reaction. Substitution, nucleophilic, bimolecular, and where CH R aa gaya, matlab you have replaced the one hydrogen with the other hydrogen. You can do two different types of nucleophilic. So because there are two hydrogens, you can replace both the hydrogens with the alkyl group. So they have done double this substitution reaction. Pehle, with the base, they abstracted the hydrogen, reacted with alkyl halide, formed the first substitution product. Again, for the second time, reacted with the base, formed a negative charge, again substitution reaction, and you can see two different or same alkyl groups being attached. Then the last step would be the removal of this malonic esters. So by HCl in the presence of any acid or dilute or a strong, normally we take a strong, we'll remove these ester. This is called as hydrolysis, and you could get either a monoalkyl acid or a dialkyl acid. अगर दो बार substitution करेंगे, we will end up with a dialkyl acid, and अगर हम एक बार substitution करेंगे, we will get a monoalkyl acetic acid. I repeat again, this is malonic ester. This malonic ester contains a CH2 group. This CH2 group is sandwiched between two carbonyls. Yesterday, I drew the resonating structures of this malonic ester and signified the importance of this compound as a compound which is quite acidic in nature. So drew the or we made a comparison of the acidic strength of the various organic compounds. So I drew alkane, I drew alkene, alkyne, carbonyl, and a compound with two carbonyls. So where I found out that the compound which contained two carbonyls, which has a CH2 in between, is highly acidic in nature because I'm able to draw more resonating structures which are stabilized. So I could draw carbon ions and enolate ion which were stabilized, which were distributing the negative charge on the framework of the structure. So this is the importance of malonic ester as a compound which contains an active methylene group, is highly acidic in nature. So I will react it with the base. I can abstract this proton, which will acquire a negative charge, and on reaction with Rx, which is alkyl halide, I can form a monoalkyl acetic acid kind of a compound. And since there are two hydrogens, so two different types of substitutions can be done. So I can end up with a dialkyl acetic acid and also with the monoalkyl acetic acid. So this is the basic chemistry. So this is the basic chemistry of the malonic ester as a compound used to synthesize various different kinds of organic compounds. So the first synthesis is a synthesis of an acid. So if you ask to prepare an acid using malonic ester synthesis, so you will be asked direct question, synthesize N-butyric acid using malonic ester chemistry. So in the next video, let us see how malonic ester